Welcome to our webinar to speak about heat stress. My name is Aurélien PIRON. I am a Ruminant Technical Manager for Lallemand Animal Nutrition. And I am very happy to be here with you to discuss about this hot topic, which is heat stress in ruminants. So, as you may probably know, heat stress is impacting farm profitability. Different studies show that heat stress is having a huge impact on animal performance and finally farm profit. On dairy, average losses can reach up to 120 euros per cow per year. On beef, it has been estimated that the losses in terms of body weight can reach 10 kilograms. For sure, these can vary according to the challenge, but also animal genetics and farm management. Some recent research also demonstrated that heat stress can also have long-term negative effects. This can even start before birth, with a poor development of the animals through low growth and gland tissues development. Baby calf health is also affected, with animal reaching high rectal temperature but also inflammation. What is important is to handle, let's say, temperature into the barn. And the objective is to set up action to maintain temperature close to 21 degrees because we know that this is where especially cows, are, let's say, in a good shape. First, this starts from the barn design. We need to make sure that everywhere there is ventilation in the barns to cool the animals all over the day, all the day of the week. Then access to water is important. 10% of the herd can drink at the same time, and within 1 minute, 20 liters of water should be, let's say, ingested. Dry and fresh, but also calving cows must also have access to, let's say, fresh water. The roof is also important to limit the heat stress on animals. Light colored, but also sprinkler system on the roof can limit this temperature rising. Feed is also very important. Keep the feed cool as possible. And for sure, work with your nutritionist to minimize subacute rumen acidosis. Work planning cows. Make sure that the work is not too much on the hottest time of the day. What does it mean? Avoid to move animals, to make treatment on them when the temperature are the highest all over the day, making them resting during this hot period. The fourth point is about cooling. You need to make wind to make sure that the cows are cooled with soaking air cooling that will help to evaporate the water that they have on their body. Heat stress is affecting animal behavior, and visible signs have been recorded. The first one is that animals are lying down and ruminating less, this time are depressed. We also know that the respiration rate is increased, and this is a clear sign of signs of heat stress. Animals, as you can see on the picture, are also usually panting, which is inducing a loss of saliva. Feed intake is also, let's say, affected with a big depression of it. Manure is also affected. Color, consistency will change. And under high heat stress condition, we know that locomotion problems can occur, leading to laminitis and cows which are also reducing their intake on this way. So keeping the situation as cool as possible is very important to reach the, let's say, barn temperature of 21 degrees as a target. Again, ventilation is very important. Water supply again is crucial. The roof is also important. When it comes to nutrition and feed, preventing rumen acidosis, improving rumination time and feeding behavior is very important. For this aspect, we must take care of the diet composition. Avoid silage eating and having a digestible diet with a high quality forage. Again, making sure that animals' behavior and resting time is enough all over the day is very important. And finally, cooling cows to avoid any stress handling during the hottest time is very crucial. Now, what is important for you as a manager is to ensure a good monitoring of the temperature and humidity index. Always looking at visible signs to identify and evaluate the impact of this heat stress. Don't forget dry cows or young stock, which is the future of your farm, but also making sure that the barn is well designed with a comfortable and hygienic bedding. And we need to consider to start prevention as early as possible before the temperature are rising, and to continue also after heat stress to have the best recovery as possible. In ruminants, feed efficiency is driven by the capacity of the rumen to transform the feed into energy and protein thanks to a balanced microbiota. Let's focus on it. Heat stress is modifying the ruminant behavior related to rumen function and animal performances. Under high temperature and humidity, animal comfort is affected, leading to high respiration rate and lower laying time. In beef, field experiences show that animals are more aggressive. This will affect eating behavior with a reduction of meal size. Meal duration and frequency will also be lower. Animal, at the end of the day, will ruminate less. As a consequence, rumen microbiota balance and activity is negatively affected, leading to a high risk of rumen acidosis. And for you, as a on-farm nutritionist, farm managers, this is very important because this will affect animal performances in terms of milk yield and milk component, fat, milk fat especially, growth for beef cattle, and finally overall feed efficiency. Animals could be also more prone to liquid feces, inflammation problems like locomotion, red horns, red feet, and potentially to a higher morbidity, including mastitis in milk-type animals like dairy cows. Heat stress affects rumen fibrolytic microbiota. A research group from Japan has shown how exposure to high heat, high temperature, and high humidity affects the rumen microbiota. They observed significant shifts of microbial population. When we analyze the evolution of these different groups of bacteria, they have been able to measure that under heat stress, they found a decreased relative abundance of what we call structural carbohydrate degraders. Those bugs are very important because of fiber degradation, and in that particular case, this will limit fiber degradation. They also saw an increase of relative abundance of rapidly fermentable carbohydrate degraders. Among them, many bacteria are producing lactic acids, which is leading to a lower rumen pH. As you can see, this is also confirmed by other studies using some continuous rumen pH measurements, where researchers demonstrate that under heat stress, there is a depression of rumen pH from 0.1 to 0.4, which is very important. So now let's detail how our solution, Levis LSC, a rumen-specific live yeast, can positively affect ruminant feed efficiency and, at the end of the day, improve feeding behavior. This is supported by our audit system that can help to evaluate with practical indicators how rumen efficiency is into your farm. This live yeast strain of Levus LSC has been validated in more than 100 publications on its beneficial effect in the rumen. This active dry yeast was selected for its specific attributes by Lallemand, recognized expert in yeast and bacteria, and one of the leading manufacturers on this microorganism. Feeding Levus LSC has been shown to improve rumen efficiency, which result at the end of the day in a positive impact on the negative effect of heat stress. First, Levus LSC will enhance the microbiota balance. Second, by scavenging oxygen, Levus LSC will improve the anaerobic condition. This will result on a maintained rumen pH at a better level, preventing acidosis, but also enhancing fiber degradation. And these beneficial actions are also validated under heat stress conditions. Some trials has demonstrated that Levus LSC is improving rumen pH and feed efficiency under this condition. But also, these are validated on other aspects like eating behavior, animal inflammation, measured outside by the horn inflammation or feet inflammation. So thanks to those positive effects, Levus LSC is helping to enhance this feed efficiency through a better behavior and reduced inflammation. Levus LSC improve rumen efficiency. First, let's speak of the rumen pH. We have demonstrated that under heat stress condition, using the recommended dosage at this stage, we improve rumen pH from 5.99 in the control to 6.26 for Levus LSC. And this is strengthened by other data provided by other research in different conditions. Levus LSC on dairy, on beef is improving rumen pH. On beef and dairy, feeding behavior is also improved. On the left side, a trial conducted at Texas A&M with a similar dry matter intake, animals fed Levus LSC presented a different feeding behavior. Frequency of visits was maintained or stimulated using Levus LSC. Animals are taking more time to eat. Meal duration during the day, meal frequency during the event was increased. Animals were eating slower. Eating rate was decreased. These behaviors participate somehow to a good prevention of acidosis, especially during heat stress. On the right, on dairy cows, this has been also confirmed in ruminants on dairy cows. Cows fed Levus LSC tend to have more chews per kilogram of dry matter intake. Rumination activity is improved. Interval between rumination bouts tends to decrease, as you can see on the graph. Lallemand is investing in science. In 2020, a recent publication in Journal of Dairy Science by the team of Professor Jose Santos from the University of Florida brought new information of the Levus LSC effect on heat stress. It indicates that this rumen-specific live yeast has a positive impact on rumen pH and feeding behavior. This helps to drive dairy cows' efficiency and animal performance during heat stress. As a consequence, this trial demonstrated that Levus LSC was able to reduce inflammation risk. Levus LSC fed cows has a lower serum amyloid A, which is a compound excreted from the liver during inflammation episode. Some Published evidences has demonstrated the positive effect of Levus-LSC on rumen wall integrity. A recent article from Dr. Bach demonstrates that supplemented cows has a reduced rumen inflammation. This leads to a lower cytokine gene expression from the rumen wall. Thanks to that, Levus-LSC would limit the transfer of those inflammation messengers to the liver and reduces by this way its expression of acute phase protein like serum amyloid A. We described previously that fibrolytic microbiota is affected during heat stress period. This will affect for sure fiber degradation. This trial confirms that Levus-LSC fed cows has a significantly higher dry matter digestibility and also NDF digestibility. Interestingly, Professor Jose Santos concludes that the improvement in feed efficiency is likely related to an improved digestion of fiber. Because of direct effect of the live yeast on rumen microbial metabolism that favored a more stable ruminal environment. The changes in feeding behavior with increased showing time per unit of dry matter or NDF consumed should also favor optimized digestion with reduced acidosis. An interesting conclusion. Levus-LSC enhance fiber degradation. Here in the graph, you have a summary of an important database which is combining more than 240 ingredients that demonstrate the benefits of Levus-LSC. We will not go into details, but it's clear that Levus-LSC is a solution to improve fiber utilization by dairy cows. Levus-LSC improves rumen efficiency and feed efficiency. During specific heat stress challenge, Levus-LSC improve milk yield from 1.4 to 2 kg per cow per day. Feed efficiency is also improved from 7.6 to 8.5%. This clearly demonstrates the beneficial effect on farm profitability. In beef cattle under heat stress, Levus-LSC also improve feed efficiency and growth. This has been demonstrated in multiple trials. This trial that you see on the slide was conducted in Italy during the summer 2015 in a large intensive beef operation. It was an opportunity to use policies that are assessing rumen pH all over the time. As you can see on the graph, during the trial, the THI progressively increased to 70-80. At the same time, the pH was evolving with a reduction in the control, whereas the Levus-LSC is still having a stable rumen pH. At the end of the day, the difference in favor of Levus-LSC was an improvement of rumen pH about 0.5% point. In this study, also the growth was followed, and we see that Levus-LSC improved ADG by almost 10%, which mean a better resistance to heat stress. Visible signs were also assessed, and it was clearly visible that Levus-LSC was reducing the inflammation of horn in such conditions. As a summary, Levus-LSC excels under heat stress conditions, both in milk type and meat types ruminants. On dairy cows, milk yield and feed efficiency are increased. On beef, growth is enhanced. Moreover, ruminant welfare is improved. It could be either through a better feeding behavior with longer rumination time, but also through a reduced inflammation like in beef, where red horns are reduced using Levus-L. Recent studies demonstrate that baby calves are also sensitive to heat stress. Poor gut health are affecting short-term and long-term baby calf performances. Exposure to heat stress causes poor growth performance of calves and beef. And this is mainly due to the reduction of feed intake, but also because of altered, let's say, physiological status, including endocrine and immune system. Therefore, we can see also an intestine disbalance and pathogen development, especially under heat stress, which will turn in a reduction of the gut integrity, inflammation, let's say, of the animal with the excretion of cortisol, for instance, which will lower the natural defenses. And this will induce important visible signs: diarrhea, high rectal temperature, and even dehydration. And in the other word, morbidity and mortality and lower animal performances. So heat stress is really affecting animals' behavior. Lallemand has selected a major microbial solution that is proteinative milk. It's a specialized formulation with a unique active dry yeast probiotic Saccharomyces cerevisiae boulardii CNCM I01079, which has been shown to help reduce the negative impact of stress in cattle. In a trial conducted in Korea, proteinative shows a significant decrease in diarrheas, as shown by the fecal score here. And this especially occur during heat stress season. This improved health was also visible by monitoring the rectal temperature. And again, as you can see, proteinative was reducing this rectal temperature in both neutral temperature but also heat stress period. Moreover, proteinative decrease the pathogen shedding through the measured by the E. coli in the feces, also reducing the heart rate, so reduced inflammation, which was turning in the reduction in the blood cortisol and haptoglobin, especially during the heat stress period. In another trial conducted in Nebraska on beef cattle, where the stress by induced through the intravenous injection of lipopolysaccharide, LPS. During this trial, it was observed an increase of cytokines, as you can see here, in the control group, as you can see, whereas in the proteinative groups, we have a maintained, let's say, level of inflammation through modulation of these cytokines expression. In parallel to this inflammation modulation, we can see on the graph on the right that the rectal temperature, which is some kind of external sign of inflammation status, was decreased with proteinative after the challenge compared to the control. As a conclusion of this trial, proteinative is a good strategy to consider to limit the negative impact that the animal can face during its stress. Finally, recent studies demonstrate that baby calves are sensitive to heat stress. Poor gut health are affecting short-term and long-term the animal performance and especially the immunity. Heat stress is affecting the respiration rate. And we know that higher is the breathing rate, higher will be the oxygen into the body, higher will be the oxidative stress. Some research have demonstrated that high level of oxidative stress is impairing the immunity. And this will have negative consequences on the animal, decreasing the conception rate, increasing the level of somatic cell count into the milk, increasing the level of mastitis, and all related health problem that can even include mortality. This slide demonstrates that how heat stress can impact antioxidant status. Different studies mentioned here have found that under heat stress, superoxide dismutase activity is reduced. So superoxide dismutase is a key enzyme when it comes to antioxidant status. Peroxidation of lipids is increased. And this will lead finally to the production of a high, let's say, quantity of free radical on the animals. And this will, at the end, impact negatively animal immunity. Some data also have reporting the impact of heat stress on meat quality. If you look at the picture on the top right, you can observe different quality of meat. With, at the right of the image, the dark, firm, and dry meat. And this can be impacted during heat stress. Some researchers have demonstrated that during summer, the percentage of these DFD carcasses are increased in summer. And this is mainly related to the pH of the meat, which is higher, and also reduction of tenderness and brightness. And this is really coming from a lower antioxidant status of the animal. So low antioxidant status is occurring during stress waves. It affects animal immunity. Supplying antioxidant product like highly bioavailable selenium is important to maintain a good status during challenging period. Feeding alkocell is increasing the activity of glutathione peroxidase, which is one of the most important enzymes involved in the antioxidant chain. Feeding organic selenium versus selenite is also increasing blood and milk selenium. This shows a better selenium bioavailability compared to these inorganic sources. On dairy cows, it's well demonstrated that selenium level is affecting somatic cell count. Multiple studies have demonstrated the positive effect of alkocell supply on milk somatic cell count. The reduction can reach 30%. And this will have positive impact consequences on mastitis occurrence and animal morbidity. As we saw before, beef cattle are also affected by heat stress. Alkocell supply is also improving beef selenium and antioxidant status. This study shows that supplying alkocell to beef increases the level of blood selenium, but also total antioxidant status. We can see that feeding alkocell during the entire period is very positive. But even a supply during the last 70 days is already a good nutritional strategy to increase the status before to get slaughtered. Feeding alkocell to beef is improving meat quality. The study presented in the slide before also measured some meat quality parameters. Meat selenium is increased, and drip loss, which is quantifying the amount of water leaving the muscle during aging, is reduced, as you can see on the graph. This clearly demonstrates the interest of feeding alkocell during heat waves on muscle quality. As a conclusions, ruminants are affected by high temperature and humidity conditions. Their behavior is strongly impacted, which can be visible at farm level. And this can lead at the end of the day to a reduction of milk yield or growth for adults, but also increased young stock morbidity. This will not only impact farm performance in the short term, but also in the long term, animal immunity can suffer. And all this leads to issues like mastitis crisis, fertility, which will at the end affect farm profitability. So as a nutritional strategies, it's very important to, for sure, abat the heat, reduce the heat through a good barn management, a good cooling system, but also through nutritional strategies. To maximize, let's say, the energy supplies to animals through a good diet digestibility, a good feeding behavior, through the supply of a rumen-specific live yeast like Levuselaceae, but also to prevent all kinds of stress and the related issues. To prevent rumen acidosis and inflammation through again the use of Levuselaceae, but also to support the immune system and at the end fertility through the use of organic selenium from Alcocel, but also to maintain a good pre-ruminant gut health through the use of a specific live yeast pre-alternative milk. But again, this very important nutritional strategy is part of an holistic approach encompassing farm management to limit its stress challenge. I thank you for your listening, and it's open for some questions. Thank you.